Let's do the lack operon question that was in the homework. Before we start, let's just visit very important concepts. Not concepts, but like rules of thumbs when it comes to operons. Actually explains the concept as well. So if I have an OC, that means the operator, there's a mutation in the site where the on the operator where the repressor binds. So no matter what kind of repressor I have, it will not bind to the operator, and so the operator will always be functional. So this operator is invincible. It will always be optional regardless of what type of enhanced repressor I have. IS means it will, if I have a normal operator, it will bind to it indefinitely, like forever. Like there's nothing that would separate it from the operator. That's it. It's a super suppressor. Once it's there in the system, it's gonna suppress and not leave. And then I have the I negative, which means it will never ever bind to the operator. Again, let me draw this here. So I have my promoter, have my operator, and then I have my like Z, Y, and A. So when I have a super operator, regardless of what repressor I have, right? Remember, it's lac I, which is the repressor. Regardless of what repressor I have, nothing will bind to it. When the lac I has an S substrate, it means it has this mutation that lactose will not bind to it. So here, remember, lactose usually binds here and releases it from the operator. So in this case, there's a mutation here. So lactose cannot bind to it, and so it will forever be bounded to the operator. Lac I means it has a mutation at the site where it binds to the operator, and so it will never bind to the operator because of that mutation. So here, never bind. And then we have our normal lac I, which will then have a positive on top of it. So this normal one binds to the operator, and then when lactose is present, lactose will bind here, it will leave the operator. So this one is the only one dependent on lactose. The other three are not dependent on lactose. So this one depends on lactose, and if lactose is present in the system, operator is on. If lactose is not present in the system, operator is off. Okay? So how do you approach this kind of question? First thing I would do is I will write down which types of lac I have. Both of them are the normal ones. Then as soon as I see if I have negative promoter, I just cross it out. Same with this one. So I have IS I negative. I don't have any negative promoters, I'll leave it alone. Here I'll have I plus I negative, have a negative promoter, so I will cross this out. Here I have I negative, I plus, so I have a negative promoter, so I will cross this one out. Okay, so in this case I have, it would be nice to draw it really fast, so I have promoter, operator, Z, Y, A, right? So my operator is C, so it does not care about the other if there's a repressor or not. It will always be active. And I have my Z and Y and A are positive. That means I'll have the three proteins functioning, or enzyme and proteins. So so they'll be expressed. And then for the next one, again, I'm gonna do this really fast. P O Z Y and A, and then apparently I have both of them active. B Z Y and A. If you can do it without drawing this for yourself, you're great. I can do it without drawing, but it's sometimes easier to draw, and then with practice you can do it without drawing it. So Z here is negative, so it's as if Z does not exist. So plus and plus. Z here is positive, Y is negative, A is negative, so it's as if Y does not exist and A does not exist. Here I have operator that will never be blocked by any repressor, so I know that this will give me Z indefinitely, so it will give me Z. This one will transcribe Z, Y, and A, and it will translate them into beta gal, primase, and the other enzyme. For this one, since Z will get transcribed, then I'll have beta gal. But then again, so we said this one does not care what kind of repressors I have, but this one is my normal operator, so the super suppressor, so this one will not bind to any operator, so it doesn't matter. This one will bind to my O positive, so it's as if this is not active, and so I'll only get Z. Again, it's because I'm explaining it, I'm going slow, but then when you do it and practice on your own, you're gonna be a lot faster. So let me draw here. P O Z Y and A. My operator will not bind to any of the repressors, so those repressors don't matter. Obviously my promoters are positive. The only reason I'm drawing this is because my promoter is positive, so it doesn't, even if I don't put the positive, I know that this promoter is active because I already crossed out the negative promoters. And then here, my Z is positive, my Y is negative, my A is negative, so I know that lac Z will be transcribed, and hence beta gal will be transcribed. It will translate into beta gal. Okay, here, let me draw this one. So I have B, O, Z, Y, and A. I have wild type operator. I have negative Z plus A plus Y. So since Z is negative, it's as if we're not gonna make any Z's. This I will not bind to any operator, so this one does not count. This I or lac I depends on lactose, right? So if lactose is binded to it, it will allow the operator to function normally. So that's what we mean by normal induction. So I will have normal induction of Y and A, which will give me primase, and the other enzyme. So this one the answer for this one is B. So 4 is B, and as we saw, 3 would be C, and 2 will also be C, and A will result in Z, A, and Y. 1 will result in Z, A, and Y, so it does not represent any of them. So A, the answer for it is none. B, it's gonna be strain 4. The crosses from the fourth one, and then for C, it's gonna be 2 and 3. Try to practice on your own, and it's supposed to work with all other possibilities. Just remember to isolate. Step 1, just isolate your repressors, whether they're minus, super, or wild type. Number 2, cross out all P negatives. Number 3, draw your operon really fast. P O Z Y A. 4, cross out mutated ones or inactive ones. Example, you have a Z negative, you cross it out from the drawing. And then 5, check if the repressors interact with operators, otherwise cross them out. And that's it. Then you're gonna know which what's the result of translation. So it's like the whole operon will be transcribed, but which ones will give you functional proteins or enzymes. And that's how you solve such questions for lack operons in this case. Thank you, and hope this works.